Hello, and welcome to a little lesson about transforming linear functions. In this lesson, we are going to specifically focus on linear translations. Let's go. To begin, let's do a little warm-up of graphing. The way we graph lines from their functions are by identifying their slope and y-intercept. The slope here is 2, which means our slope is actually 2 over 1. Our y-intercept is -6. All right, we're going to start by putting a dot on B, our beginning, which is -6. And then we're going to move up 2 spaces, to the right 1 space, and that is all we need for our line. Make sure to use a ruler or your ID. I'm doing this on the tablet, so it's not going to look that good. But we connect them in as straight of a line as possible throughout the whole graph. Let's do that again for number 2. What's the slope here? This is weird. It's just a negative. What invisible number is it really? That's right, it's -1. And since it's -1, we're going to make it into a fraction, -1 over 1. We make every whole number a fraction over 1. Our y-intercept is +1. So we're going to start by putting a dot on +1, and then following our slope down 1, right 1, and then connecting those 2 dots. Okay, now let's move on to vertical translations. A translation is a type of transformation that takes every single point of the function and moves it the same distance and direction. In this case, we are going to be doing vertical, which means up and down. In the example on the right, you should see that there's f of x, and then we translate it down 5 by subtracting 5. And you guessed it, adding will make it go up. So what we're going to do first in number 2 is write the new functions. Then we'll actually do some graphing. So let's start with that. If the original function is f of x is 5x minus 8, and g of x is f of x plus 7, what we're going to do is solve for g of x by rewriting what f of x is, and then plus 7. Do you see some like terms here? By like terms, I mean things that we can actually add and subtract together. So we can only add x's with other x's and regular numbers with other regular numbers. Hopefully you can see we have a -8 and a 7. 5x stays 5x. -8 plus 7 becomes -1. That's our new function, 5x minus 1. Adding, oops, I want to do this. Let's just jot this down. Up 7. In letter B, we have subtracting. That's down 11. Okay. In letter B, we have what h of x equals, and r of x is h of x minus 11. Let's find the new function. So 6 over 7x plus 2 is h of x, and then I subtract 11 from it. Once again, we're going to combine some like terms, the 2 and the minus 11. Our slope stays 6 over 7x, but then our y-intercept is -9 because we moved down 11. Let's try that one more time for letter C before we start graphing. Okay, in letter C, a of x is 19x plus 52, and we're going to, oh, that's a typo. That's supposed to be a. Well, that's too late. I already printed. That should be a of x plus 13. Well, let's find q of x. A of x is 19x plus 52, and to get q, we add 13. Once again, we're going to add some like terms. 19x stays 19x. 52 plus 13. Whoa, I don't know what I did there, but it equals 65. Fantastic. Okay, wonderful. Now, let's graph transformation so you can see how it actually looks like. Okay, I have already graphed the original graph, so f of x is there already. We don't need to graph it. What we need to find is g of x. So if g of x is f of x plus 3, well, let's figure it out. G of x is going to be 2x minus 2 plus 3. Right? So let's add some like terms. It'll still have 2x as its slope. And then negative 2 plus 3 is positive 1. Don't forget our slope is actually 2 over 1, right? No, let's erase it. I don't like how I wrote that. Let's try that again, Gumin. Okay. 2 is actually 2 over 1. Don't forget that. Okay, let's graph our transformed function. Remember, adding means we're going up, so we should see our line go up. I want to use a different color. Let's use green. All right, we start at positive 1, and then I go up 2 to the right 1. We're pretending I'm drawing a nice straight line. You're drawing a nice straight line because you're using your ID or a straight edge. Hopefully, you could see that we went up. All right. Letter B, let's do the same thing. First, let's find s of x. So s of x is going to be rx minus 5. So that means negative x plus 4 minus 5. Remember, subtracting means we're going down. So hopefully when you graph this, we'll see that our graph went down. First, let's combine some like terms. 4 minus 5 is negative 1. And let's not forget, this slope of a negative is actually negative 1 over 1. Let's graph it. Okay, so I'm going to start by putting a point on negative 1. And then I'm going to go down 1, right 1. Ugh, I was going to do green, I forgot. Hopefully, you can see how this line went down. All right, let's do a couple more. Letter C. Let's find g of x just like we've been doing by plugging f of x in and adding 11. Well, here, adding 11 is going to take us up 11, so we should see that happening. Let's combine these like terms. So g of x is negative 2 over 3x, which means we're going to be going down and to the right. Negative 4 plus 11, oh no, is 7. Why? Thank you. You saw that how? Oh, we'll see in the recording, but I'm not starting this over. Psh. Okay. First things first, let's start by putting a dot on positive 7, because that is our y-intercept. Our slope is negative 2 over 3, so I'm going down 2, to the right 3. I did choose to go up for a pretty big number, so I went up 11. I was hoping that it'd make it much easier for you to see that this graph went up. Right, last two. Let's try letter D, where we're going to plug a of x into b of x. And we're going to subtract 3 from it. Subtracting is going to be moving our graph downwards. Negative 2 minus 3 is negative 5. Okay, let's graph it, and hopefully you'll be able to see how this graph moved down. Okay, we start at negative 5, because that's our y-intercept. And then we're going to go up 5 to the right 4. 1, 2, 3, 4. 5 to the right, 1, 2, 3, 4. Hopefully, you can see how this line moved down. All right, last one. Let's do it. Letter E. We're going to plug C of x into D of x. We're subtracting 10 again. Or not again. We're subtracting again, which will be going down. Let's combine these like terms. So we get 3x minus 3. Let's graph it. First, we start with a point on -3. And don't forget, 3 as a slope means 3 over 1. So we're going to be going up 3 to the right 1. And we'll be drawing a line, pretending mine is straight. This one's a little harder to see, but we did go down. Okay. Those are our vertical translations. If you have any questions, please don't hesitate to ask me or whoever else is helping you with it. Otherwise, have a wonderful rest of whatever day it is for you. Bye!